Hello everyone. Today we are going to discuss a quick visualization of atoms. Like how atoms look like. We have already learned in atomic structure that there are different models. So I am here going to make them a quick summary so that we can easily see and visualize that what is going on inside an atom. How electrons are oriented inside an atom. So, if we want to give a topic name, we can write visualization of an atom. Visualization of an atom. So, I will make it very brief. First of all, the first atomic model was given by J.J. Thomson. What was that? It was kind of plum pudding situation. We can think of in a plate there is a pudding which is positively charged and some negatively charged are kind of plum on top of a pudding, or similar analogy like a watermelon. The cross section of watermelon can give some red area which we can think of positively charged, and the seeds, black seeds, we can think of negatively charged. But this was the first model of an atom which was not accurate at all. Why? Because when Rutherford trying to pierce through some atom using alpha particles, what you already know, the famous Rutherford gold foil experiment. So almost all of the alpha particles which was positively charged can go through inside an atom. So this model was wrong. You already know that. So what was the next model given by Rutherford model? Rutherford's atomic model. So Rutherford told that atom is almost empty. You can think of there is a tiny positive charge and everything is empty. This is very tiny positive charge. This is called nucleus. And outside there is some electron are moving. They Rutherford did not exactly specify how they are oriented, how they are moving, but Rutherford says it is rotating outside and nucleus, and almost everything are empty. That was the model which was justifying that piercing through of alpha particle can pierce through this empty space, right? So it could justify that situation. That's why this was the model, Rutherford model of an atom. Let me erase this one to make it more clear. So this was the model. So this was very basic model of an atom. There is a nucleus, very tiny. Let me make it big so that you can see it more. Tiny nucleus and electron can revolving. But there was a also drawback. What was the drawback? That this electron, if it is constantly moving, so it is accelerating because velocity is, direction is changing, acceleration is also happening, and in presence of another charge, it can release energy and it can go inside the nucleus by losing energy in a spiral fashion. So that model was also wrong. Also, Rutherford could not specify how exactly electrons are oriented. So to make it more clear, Niels Bohr came into the picture. Niels Bohr's atomic model. So Niels Bohr atomic model corrected that situation and told that obviously there is a nucleus and electrons are revolving in a circular fashion, kind of 2D situation, not three-dimensional. Nucleus like a sun and earth is rotating, revolving around the sun. That is a two-dimensional situation, right? So it is a two-dimensional situation. So in this two-dimensional situation, Niels Bohr corrected that these revolving paths are in a fixed energy. That's why this these paths are called orbit or shell, but which orbit? It's called stationary orbit. I am just summarizing all the models to make it more visualized, to make it more clear to you how atom look like. I am not explaining everything in detail. I am making a summary. So this was the model where we can think of there is a positive charge and electron are revolving in a 2D circular path. But this model was not enough to justify some specific experiment which is called fine structure of hydrogen atoms. Also, there are spectral line in the hydrogen. Also, there are new models are coming out. Scientists de Broglie said that electrons are not particle, so we cannot justify it is a particle. So there are new mechanics, new theory was coming out, which is the modern theory of any atomic model, which is called quantum mechanical model. And I will try to emphasize that one, and I will try to make it more comfortable to visualize how exactly electrons are present outside a nucleus. Let's talk about the third model. The fourth one. The fourth one is quantum mechanical model. So, quantum mechanical model is that electron is neither a particle nor a wave. It kind of both. So, if there is a nucleus and a wave is there, so we cannot exactly say that what is the position of that wave. We cannot exactly determine what is the angular momentum of the wave. We can determine a relative position or a relative momentum, which is, according to Heisenberg, position error and momentum's error multiplication must be greater than equal to h by 4 pi. This is the postulate of Heisenberg. So why I am just telling it, because the model you have to visualize that nucleus is there, but electrons outside the nucleus exactly where we even don't know. Now I am trying to make it more comfortable to you to think of this way. There are already different orbitals in quantum model where n equal to 1 we can talk about s orbital. You already know, right? Then also there are p orbitals where here L equal to 0, here L equal to 1, and also there are sp-d orbitals, many more. How did we get this one? By solving rigorous mathematics, which is called Schrodinger equation. But we are not going to talk about this rigorous mathematics right now. What we are trying to see, that you solving this, what is the visualization, how to see it. So for s orbital we can think of, last time we were talking about electron is revolving in 2D plane outside a nucleus, but here we can think of it's a sphere. So you can think of electron is like a sphere in one s orbital. What is the sphere visualization? Let's talk about a football. So in the center of that football, if there is a nucleus, the surface of the football, we can find the electron much more probably, rather than here electron can be found in a higher probability rather than far away or inside a nucleus. But if you can ask me that electron can be found only the surface, not necessarily at all. Here we can find that electron in a much more chance, in a much more probability, but we can also find it outside, but probability is decreasing. We can also find it inside, but probability is decreasing for 1s. So what is the visualization? Visualization is there is a nucleus and they are in a particular spherical situation where we can find the electron regularly or much more higher probability, but outside that the probability is decreasing. But we cannot say that what is the exact path of that electron. Is it moving like this or like that? We cannot exactly say. Electrons are like a cloud. We can compare it like a cloud. There is a cloud outside a nucleus which is negatively charged. Electron charge is distributed, but whole charge is giving one single electron, and that is an orbital. So visualization of any orbital is a spreaded cloud system or a negatively spread system which is representing a wave electron. So for 1s orbital we can visualize like this. So that what is the confusion behind the normal and classical thing? Normal, here we can pinpoint the electron position. Electron can go like this, but here we cannot say where is the electron. We can say here there is a higher chance of the electron finding the electron, but inside here there is a zero chance. We cannot find an electron inside a nucleus. And also here there is a very low chance. Let's talk about next orbital, which is 2s orbital. This one is really tricky. Do you know why? Because maximum teacher also inside the book, it is not properly mentioned that how it look like. Generally you will draw 1s orbital is like this and 2s orbital is the bigger version of that. But that is totally wrong. That is not the way we have to visualize it. If 1s orbital is like this, a spherical situation of probability of finding electron, then 2s orbital should be, let's draw the 1s orbital here. Then the 2s orbital should be, there is a sphere here, smaller one near closest to this and a bigger one. Means this one is 1s and this inside and outside both combined giving 2s. So that is the misconception almost every student are having, that there is only one cell. No, there is two possible cells are there. And here this space where I am marking here like this, here this space is called a node. Why this is called a node? Because for 2s electron can go here, electron can go here, but electron cannot never reach this area, this spherical part. That is nodal area. That is the visualization of 2s orbital. Means there is a nucleus. After some time electron probability is increasing. Here we can find 2s electron higher chance. Then it's decreasing, and here it is 0. Then again increasing. Here we can find 2s electron at higher chance, and then also it is decreasing in a spherical manner. That is the visualization of 2s orbital. This is very crucial because it can explain many things, something like inert pair effect. Anyway, so also another thing, that 1s orbital I was talking about. So what happening in 1s orbital? Is it interacting with 2s orbital? No, it is not exactly interacting. They are coexisting together. If we talk about 1s and 2s, they can coexist together. Why not? So something like that we have to visualize. That is the basic understanding. So I am going too far. Next I will talk about p orbital and d orbital in future. For now I think that is a basic understanding is given here. So if you have any questions, we can discuss afterwards. Thank you for the attention.